habituated or not. And so all we're modeling is the increase in pleasure that you get from going to the gym as you develop a habit. Okay, habit formation is not easy to test. So let's look at some evidence. Here's an experiment done by Gary Charnas and Ori Gnesi, who are UC professors from other campuses, and they did what I found a really compelling field experiment. Okay, so they randomly divided a group of students into 3 groups: low, high, and control. They gave all of these groups information about health, exercise, and the campus gym. And these are all people, if they're going to go to the gym, they're going to go to the campus gym. They don't have a lot of options. And then they introduced the following experimental manipulation. Okay, the low group received a $25 offer to attend the gym one time in a given week. That is a high wage for attending the gym one time. The high group, additionally, so they got that $25 to go once, and in addition, they received a $100 offer to attend the gym 8 times total in the following month or 4 weeks after that first week. So this is now $25 this week, $100 for twice a week for the next 4 weeks. Okay, so that's $12.50 per visit. So it's half the wage, but it's still quite a lot. And then the control received no offer; they just received this information. And then they recorded gym attendance using card swipe data, right? Just like you have here, you have to go and put your card underneath the laser. Okay, so if the low or high, what we're looking for is we expect people to go to the gym when you're paying them $12.50 a pop, right? The question is, do they keep going after you get done paying them more than the people that you didn't pay? And if they do, then it suggests habit formation. It's not the only possible explanation, but it suggests habit formation. So what did they find? They found this. Okay, this is time in weeks, and this is right here is the learning. What I've come to call the learning week. Let's just call it the $25 week. And this is the $100 month right here. And so we have time, negative and positive stretching away before and after the beginning of that $25 week. Not surprisingly, everybody in both of the treated groups went to the gym to get that $25. And if you take these triangles here, this is the high treatment group, the high incentive group. Most of them went to the gym 8 times during that month to get that $100. Not all, but most of them. And as you can see, most of them procrastinated a little bit. And then this blue line here, this is the control group right here. And so obviously their behavior didn't change. What we care about here is the difference, what happened here after you stop paying these people. Right? So both the low incentive group and the high incentive group wound up continuing to go to the gym more. Right? Here they're all going about the same. And here you've got these treated groups going more in the, 7 or 8 weeks after you stop paying them. Now it turns out, you can see that this pink line here is already kind of higher than the black line. Right? The black line is in there, the pink line. So it turns out that this difference here is not significantly different from that difference there. You probably can't follow my ink marks because there's so much going on here. But this difference, right, between the high incentive and the control, that difference is highly statistically significant. It may not be economically significant because it's not that many trips to the gym on average. It's about a half a trip a week to the gym, more. But it's statistically quite convincing that these people form something that looks like a habit. And we don't know how long it lasts because there's not that much data, but it seems like there's some habit formation going on there. Does that make sense? Crystal clear? So when I saw this graph for the first time, what I immediately, because what I care about isn't habit formation, it's projection bias, what I immediately wanted to know was, if I went here in time and asked these people to predict their attendance in this period, would they predict the increase in their post-treatment attendance? That's what I wanted to know. All right. So let me now just do another one of these absurdly simple models, and then I'll show you a second study. Obviously, I've tipped my hand. This is shameless self-promotion part 2. Okay, so to explore the effect of projection bias on the gym decision, let's consider a ridiculously simple model. Okay, so in the unhabituated state, going to the gym has an effort cost C, which is greater than 0. In the habituated state, this cost is offset by some pleasure eta. That's eta, which is greater than 0. Greater than C. Okay, so in the habituated state, the net utility of going to the gym, eta minus C, is going to be greater than 0. And then we're just going to normalize non-gym utility to 0 in either state. So there's no sort of physiological downside to forming this habit. Okay, so the state-dependent instantaneous utility function looks like this. The utility of going to the gym when you have no habit is negative C. The utility of going to the gym when you have a habit is eta minus C. And both the utility of no gym with habit and no gym with no habit is 0. And then we want to introduce projection bias. Okay, so there's some alpha, it could be 0 or 1 or somewhere in between 0 and 1. And this U wiggle, the predicted utility, the utility the person thinks they're going to get out of going to the gym in the future, if they're starting out with no habit, then the utility they think they're going to get out of going to the gym when they have a habit, as projected by their self in a state of no habit, is just alpha times the utility they would get out of going to the gym without a habit, their current instantaneous utility function, and 1 minus alpha times the utility of going to the gym in their true future state, which is habituated. Yeah, that's just a ultra simple model of what Lowenstein, O'Donoghue, and Rabin call simple projection bias, which you can read about in a paper, which you should read about in a paper. So it's this. It's alpha times negative C. They think they're not going to get the habit formation. 1 minus alpha times eta minus C. That's the part of them that thinks that they will. Okay. Now, what's nice about assuming that the utility function is just this additive sum, this sum of different components, right? The disutility C and the habit formation eta, is that I get to take alpha times negative C and 1 minus alpha times negative C, and that's just negative C. So this is just an ultra simple model that allows me to model the projection bias piece as simply you're going to foresee some fraction of the habit formation effect. Right? Eta is the increase in marginal utility for gym attendance that you get if you've developed a habit. And so 1 minus alpha times eta is how much of that you predict. If alpha is 0, no projection bias, then you predict all of it. And if alpha is 1, total projection bias, you predict none of it. Okay? So I appreciate that this is an almost laughably simplified model, but okay, so that's what I just said. Okay, so let's consider the decision of whether to go to the gym. And let's just imagine someone facing a decision at time 1 that is going to have impacts over 3 time periods, 1, 2, and 3. We will assume that, so this is the sort of state transition equation, if you want. So we're going to assume that going to the gym 1 time causes habituation. Now, obviously, that's an extreme exaggeration, but we can just think of this instead of going 1 time as going every day for 1 month or something like that. And then we're going to, just for simplicity for right now, we're going to assume no discounting. Okay? So going to the gym at t equals 1 results in the following stream of utilities. Right? You get negative C the first time. You have to invest something in developing this habit. And then in the future, your state variable, which I haven't really included here, is going to go from 0 to 1. I've gone from being not habituated to habituated. So I'm going to get eta minus C in periods 2 and 3. Okay? So what that means is that going at time 1 gives me a total utility, or gives this person a total utility of, I've got to pay that effort cost 3 times, but I'm going to get the eta bump twice. So I will go in period 1 if eta is greater than 3/2c, maybe, greater than or equal to, whatever you want to say. And then if there's more than 3 periods, if there's, however many periods there are in human life, then you'll go in period 1 if eta is greater than t over t minus 1 times c. And then as t gets really big, that's just simply, if the habit formation process makes it even a little bit pleasant to go to the gym over a very long time horizon, you should go. You should make that investment to go because, and by the way, this is not including any health benefits. This is just the pleasure of going to the gym. So you could map this, you could reframe this and map this onto almost anything that gets more fun the more you do it, right? Reading, going to the theater, listening to jazz, drinking, fine wine. Anything that becomes more enjoyable, more desirable, the more that you do. Okay, so those are all nice things. You could think of it as, well, you can just think of it as a lot of things, right? Drugs and alcohol is kind of a, honestly, it gets a little cliche to talk about drugs and alcohol. I'm personally more interested in habit formation that's a little bit less pathological than that. Not that I don't care about it, I think it's a big issue, but I'm more interested in stuff that's not, oh yeah, well that's like a, that's a pathological subpopulation, that's a health issue. I'm more interested in habit formation that's the kind of stuff we all experience in our day-to-day decision making. Okay, so with projection bias, what you think the perceived stream from going to T1 is that this is just gonna, it's just gonna suck in every period. In fact, that's not quite correct, right? Because if the decision is whether to go in period 1, why would I then go in period 2 or 3 at all? If you're just saying, look, do you want to go in the first period? I'm going to say, no, it's going to suck in the first period, and I'm not going to go in periods 2 and 3. So really, it would just be negative c, but either way, it's negative. So with projection bias, this person isn't going to go. Okay, so don't go. So I'm saying that's negative 3c. That's not quite right. Really, if you let this person make a decision just for 1 period, they would say, no, I'm not going to go today, I'm not going to go tomorrow or the next day either. Okay, so in this case, projection bias causes the person to miss out on a lifetime of benefits. And again, this doesn't have to be some puritanical thing about, oh, you missed out on the health benefits. This is just you missed out on this thing getting fun. Right? It's like not being willing to invest in learning to play the piano or learning how to water ski. Okay. So how could we test people's predictions? So we're going to test their predictions of future gym attendance. Now, hyperbolic discounting, this is where we're investigating one piece of behavioral economics, and we're going to have to start by wrestling to the ground another piece of behavioral economics, which is hyperbolic discounting. If people are hyperbolic discounters, then they're likely to overpredict their future attendance. Indeed, I've shown you that data already. They massively overpredict their future attendance, even if you don't pay them anything. Okay? The question is, will projection bias cause an offsetting underprediction? So we don't want to just see that people overpredict their future attendance. What we want to see is that people who are paid to go to the gym for a month, which we know causes them to form a habit, will they overpredict by more or less than people who aren't paid to go to the gym for a month? Okay? So this gets a tiny bit tricky methodologically. So here's what we did. Right? So, I meant to change. I thought I changed that. Does that say that says 2011 in your handout, doesn't it? Yeah, it's supposed to say 2011. Okay. No, not 17. It's not going to be that bad. I've been told to expect a draft tomorrow morning. Okay. So we're just going to replicate the Charnis-Ganese habit formation experiment, and then we're going to elicit people's predictions of post-treatment attendance. And we're going to do it right before the treatment period and right after the treatment period. And doing it twice is going to allow us to weed out. It's going to allow us to more accurately weed out the hyperbolic discounting feature. Okay? And then we're going to compare the change in predictions from before the treatment period to after between the treatment group and the control group. Okay. The projection bias hypothesis, if people are projection biased, then the change in predictions for treatment subjects should be less than the change for control subjects. Okay? So let me show you a diagram and I'll show you what I mean. Here's what we did. Here's the treated group T. We told them here in time, we told them we're going to give you $100 to go to the gym, not 8 times a month, but twice a week, because we wanted to make sure they actually spaced it out, which we thought would be more effective for habit formation. Turned out we were wrong about that, but that's what we did. We're going to pay you $100 starting in a week to go to the gym for a month. And then we brought them back in, so we did that. We met up in the RSF in a big meeting room there. And then we brought them back into the X lab, the social science experimental laboratory, a week later, right at the beginning of that month. And we said, oh, and actually, in fact, in this week, we gave them $25 to go once, because we wanted to learn where the gym was and how to get there and what to do and what it felt like and stuff. And then right before we actually, that treatment month began, we asked them to predict how many times they thought they would go to the gym in a series of 5 target weeks after the end of the treatment period. And actually, a period starting a week after the end of the treatment period. So there's this little dead period here. Oops. Okay? And then we brought them back in right here. Okay, so they predicted here, and we brought them back in the day after the end of that treatment period, and we asked them to make the same prediction again. Exact same prediction. Now how many times do you think you'll go to the gym? Okay? And then we did the same thing with the control group. And we had the treatment group in one room and the control group in another room, and we had actually 2 sessions of each, so there wouldn't be huge differences just based on the time of day or something like that. Okay? Now, the idea here is this. At this point in time, people's predictions may be influenced by naivete with respect to hyperbolic discounting. I really think I'll go to the gym a lot. And also by projection bias with respect to habit formation. Oh, I actually don't think I'll go as much as I will because I failed to foresee habit formation. So their net prediction might be high or low. We've seen that it's actually high. But it might be high or low depending on whether their misprediction of impatience is outweighed by their misprediction of habit. It turns out, we know that the misprediction of impatience is much more powerful than the misprediction of habit formation. So they all overpredicted their gym attendance. When we get to here, what we want to believe is, okay, these target weeks are still in the future. So they should still have the same self-control naivete, right? Because this is still, the beta is still involved and beta hat is still involved. But these people in the treatment group now know what it feels like to be habituated. Those that have formed a habit, their state change has happened. So there should be no more projection bias. So now their prediction for these target weeks should be off only by the self-control piece, the quasi-hyperbolic piece. Okay? Now, these people are faced with the same thing, but there's no change in state. So we think that the change in prediction from here to here, right, theoretically there should be 0 change, because these people aren't forming a habit. They're just impatient, and they're just as impatient sort of 6 weeks out as they are 1 week out, in theory. It turns out there's actually a fairly significant change in the control group's predictions, which either is because they start to realize, oh, actually, now that it's only a week away, I'm kind of a little bit more sophisticated about my self-control problem. That could be it. What we think it is simply we did this at the beginning of the semester. This is the beginning of the second week of the semester. People just didn't realize how busy they were going to be. That's what we think. Okay? And so what happened is that they were a third dimension of misprediction. Right? They mispredicted their own cost for going to the gym. Okay? That's what we think. We don't know. But the difference in predictions here, if the difference in predictions here is exactly the same as the difference in predictions here, then it suggests that the people in the treatment group did correctly foresee the habit formation process, and that the only thing that they mispredicted was whatever the control group mispredicted. But if the difference for the treated group is different than the difference for the control group, right? Indeed, if it's less, if their misprediction is less, then it suggests that they also mispredicted the habit formation. Okay? Because what happened is that their post-treatment prediction winds up being a little bit higher than their pre-treatment prediction, because now they realize, oh, I like going to the gym more than I thought. So the difference should be a little bit less than for the control group, under the hypothesis of projection bias. Okay, so that's what this is. So let's find out. Okay, so here's our subjects. We have more data. We ran this. We collected data for a longer period of time. This is the $25 week. This is the $100 month. This is the immediate post-treatment period. And here's this red line. That's the treated group, and it's everywhere above the blue line, which is the control group. So we got the habit formation effect. The increase was about a third of a visit per week on average. Actually, it was a subset of people going quite a lot more. Not everybody going a third of the time a week. In the immediate post-treatment period, guess what that is? What? No, it's not midterms. It's winter break. Okay. So I think the gym may be actually closed, but nobody went to the gym in winter break. Even the 5 staff people who crept into our subject pool did not go to the gym. And this is the later post-treatment period. And basically, it still looks like that red line's above the blue line a lot of the time. It turns out statistically, the habit formation went away after winter break. Okay. So we got these predictions, and we have an incentivized prediction, which is if we offer you money to go to the gym, how many times do you think you'll go? And I don't want to go into a lot of detail. And then we just ask people, unincentivized, well, how many times do you think you'll go? Forget about the money. And so what we have is we have their predictions. That's the control group's prediction beforehand and their prediction afterwards. And you can see that their predictions went down because they kind of wised up. We think the story is they wised up to how hard it is to get to the gym, in the middle of the semester. The treated group similarly overpredicted their attendance. Their predictions also went down, but by a little bit less. Now, when we look at these financially incentivized predictions, we find a pretty tiny difference, right? But when we look at their unincentivized predictions, we actually find a pretty significant, right? We find that the failure to predict the habit formation effect in the treated group is actually slightly larger than the habit formation effect itself. Okay? We then did a big, fancy, complicated generalized method of moments estimation of the structural parameters of our model, and what we found was that our best estimate of alpha is 1. People were completely projection biased with respect to this habit formation process. Okay, so that doesn't prove. This doesn't prove that that there's habit formation. Doesn't prove that there's projection bias. But that's how we think it suggests that might be what's going on. And I'll skip the welfare implications because I think I already made that pretty clear. All right, see you next week.